Mr. Schweitzer decides that he wants to be the first chemistry teacher on the moon. He builds an acetylene rocket that propels a giant rubber cork off of a track 60 meters high and into the air. His velocity upon leaving the track is 20 meters per second, and by the time he hits the moon, 484 million meters away, he's achieved a velocity of 600 meters per second. I want to know A, how long was his trip, and B, what was his acceleration during the trip? So let's write out our equations and set up our variables as per usual. T plus 1 half t squared. So I'm doing this, I want you to think about how would I solve this? What are the variables I'm missing? What is my process for figuring out how to solve these problems? Variable list. So, writing out our variables, he's starting at 60 meters. He's ending at 484 million meters. It's going to be his initial velocity is 20 meters per second. His final velocity, 600 meters per second. Those are all values that are given to us. So, what am I missing? Missing acceleration and time. So, can I use either of these equations to solve this problem? I can't. Because I know that there's an acceleration, 20 meters per second to 600 meters per second. That's a change in velocity. There has to be an acceleration. And I know there's got to be a time. There's a movement over time. There has to be a time. I'm missing A and T in this equation. I can't possibly solve it. I'm missing A and T in this equation. I can't possibly solve it. What can I do? I can make Frankenstein. So the key here is that an equation is just as valid as a number. It doesn't matter what I've got. I can always substitute an equation in for a number. The reason for that is the math works the same way. It's all the logic. All of these equations are somehow derived in the first place. So I can adjust them and move them around as necessary, as long as I maintain the logical ratio that this equation represents. So I'm going to use my acceleration equation in place of acceleration in my S equation. So this is a little bit more complex to set up and think about. But once you've got this one figured out, once you realize how to set up this problem, it actually simplifies itself right down. It becomes extremely easy to solve. And that's why I actually love these kinds of problems, because they really make me feel smart, because it looks really complex, and then it's really easy to solve once you know how to do it. So once this clicks, you guys are going to feel like geniuses every day. So S is equal to xi plus vit plus 1/2, and substituting this equation in is going to give me vf minus vi over t times t squared. Now, I'm going to look at this part real quick. I'm going to get specific on how this algebra works. So let's bring it over here and just look at it. So I've got a 1/2 vf minus vi over t times a t squared. If I simplify this, I want to put my t squared inside these parentheses. And I'm going to ignore that 1/2 for now, because it's not going to do anything yet. So I'm just going to get rid of that. To put my t squared in here is the same as writing t squared times vf minus vi, all of it over t. these ratios are maintained. If you want it, you can go ahead and pick a few random numbers and punch them in for this, punch them in for this, and prove that you get the same values. Now, once I have this, t squared over t, what does that become? Well, t squared is really t times t. So t squared over t is t times t over t. It's a mouthful, but it makes sense, right? Well, anything divided by itself is 1. If I have 3 divided by 3, I have 3 parts of 3. That means I have 1 whole part. So even a variable, x divided by x, is going to equal 1. If you ever see that in any equation, you can simplify that to a 1. So t times t over t, I'm going to get rid of one of the t's on top and the t on bottom, because that's going to equal t times 1 over 1, which t times 1, anything times 1, is itself. So it's going to give me t. So when I do this, I drop out a t, and I drop out my square. And that leaves me with vf minus vi times t. Okay? That's going to end up being the same thing. So let's rewrite this, simplify. S equals xi plus vit plus 1/2 vf minus vi t. I have numbers for s, xi, vi, vf, and vi. So I can solve this equation for t. Once I have this whole part figured out, that's really not that hard to do on every problem. And what's going to happen here is because I've got that t and that t, I don't have a t squared anymore. These are the same terms. So these, once I get the math and the numbers put in, are going to merge. This is going to become very simple to solve. Okay, now that we have this all simplified, it's going to be really easy to solve. So let's plug our numbers in. Let's go 4.84 times 10 to the 8th. That's what that represents. You can plug that e in for times 10 to whatever to get scientific notation. And xi is 60 plus vi of 20 t plus 1/2. And that's going to be 600 for vf minus 20 t. Okay, now let's simplify this down. One-half, 600 minus 20, it's going to be 580, divided by 2, so times 1/2, that's going to be 290. So, simplifying everything down to 290t. Now I can add these together, giving me a 310t plus 60 equal to 484 million meters. So, 60 from this side is going to give me 483,999,940 is equal to 310t. Divide both sides by 310. It's going to give me 1,561,290 seconds. That's a long time. Plugging that in for my variable. Seconds. And let's go ahead and convert that to days so that we can actually make sense of this problem. Let's find out if Mr. Schweitzer has enough food to make it all the way to the moon. That's going to equal 18 days. I think Mr. Schweitzer should rethink his plan. Now, we are also tasked with finding acceleration. Now that we have time, we also have VF and VI. So we can go ahead, let's make some space for ourselves here. We can go ahead and use our A equals VF minus VI over T. Let's go ahead and plug in our numbers here. So that's going to be a 600 minus 20 divided by 1561290. That's actually going to give us an acceleration equal to 0.000371. And we're going to go ahead and write that in scientific notation. It's going to be 3.71 e negative 4. Okay. 3.71 e negative 4 meters per second squared. And there you have it. Thanks, guys.